All right, well, let's go ahead and get started. Welcome everyone to this Tuesday afternoon webinar, working with other CAD software and SOLIDWORKS. This is part of our 20-minute learning series that I've been working on for the past couple of months. So today we're going to look at how to best import and export files with SOLIDWORKS. This is part 4 of the 6-part learning series, and I'm Jared Spaniel, one of the product managers out of our Fresno, California office. My contact info is there on the screen, jspaniel@ddicad.com. If you have any further questions or want to contact me after the webinar, I welcome that. So let's go ahead and jump into this. I'm really excited about this one. I've had a lot of questions recently about file formats, importing, exporting, that type of stuff. So I kind of chose this topic because I think there's a lot here to go over that a lot of people don't know about or don't really utilize when transferring different file formats between softwares or between customers, or however you guys transfer your file formats. So today we'll look at broke this down into a couple sections just because there's simply a lot of information here, and 20 minutes, 20 to 30 minute time limit, I can't really give you everything. So I kind of pulled out some of the most important stuff. I want to talk about file formats and, importantly, neutral files ranked from best to worst. I've had a lot of questions on that recently about what are the best files to work with bringing into SOLIDWORKS. Then we'll quickly look at some of the supported file types that SOLIDWORKS has and how those are categorized. And then I also want to go over some of the import tools we have, such as import diagnostics, the direct editing feature to repair geometry, FeatureWorks, and then also we'll look at a quick example on importing 2D to 3D and how easy that is to make some 3D models out of 2D sketches. And then of course the why is SOLIDWORKS so great and what are the benefits of it. So I'm gonna start off with a poll question just to kind of get to know the audience here and what you guys are actually doing in industry. The question is, if you had a choice of file type to work with, what type would you choose to import into SOLIDWORKS? And I'm going to go ahead and release this question. I appreciate it if you just take a quick second and answer this. The choices here are Parasolid, a step file, IGES, ACES, or if you use some other format, that's fine as well. Just go ahead and answer that, and we'll see what kind of files you guys are using out there. I'll just wait another couple seconds on this for the rest of the votes to come in. All right, it looks like mostly everyone's voted. I'm going to go ahead and close this out so we can move on. Not surprisingly, it looks like 40% are using step files. Then IGES was second at 27%, then Parasolid. I'm surprised to see Parasolid being so low. Only 7% of people out of this small demographic here are using Parasolid, and then we have 27% using other. So basically what I'm going to do now is explain to you what the rankings are and what is best to use with SOLIDWORKS. And maybe this will change some of your opinions about what you try to utilize in the future. So if you guys didn't already know, when we talk about these types of files, we're talking about what they call dummy geometry. And basically all that is it's a mathematically accurate model, but no feature history is brought into your tree within SOLIDWORKS. So it basically just says imported, and that's all you get. You can't do anything with it. It's just a model there that you can use for form, fit, and function, but you can't really make any edits to it. So the rankings that I ranked here after doing some research and with my experience, there is some debate online. If you go on the forums, look around, see what's what, you'll find a lot of debate on a few of the files, mostly between STEP and IGES. But basically what it comes down to is with SOLIDWORKS, Parasolids are the most preferred file to bring into SOLIDWORKS. And that is because SOLIDWORKS runs on a mathematical backbone that is a Parasolid kernel. So it actually takes the files that are Parasolids and imports them in with the best translation that it can. And what this is, it's a multifunctional file that supports many model creation and editing utilities, which is also great. And it's compatible with most other CAD, CAM, and CAE softwares. So it's a great file to use. That's why I was a little surprised to see such a low amount of people using Parasolid. Although when I was in industry, we did use steps as the most common, which also makes sense here. It looks like steps are the most common based on the poll. And I actually wrote that most widely used data exchange file, a step file. Step file stands for Standard for the Exchange of Product Model Data. So also a great file to utilize. No problems with it. Go ahead and keep using that if you like it. The next one was IGES. So IGES is an initial graphics exchange specification. And these files were actually developed and utilized by the United States Air Force for aerospace manufacturing industry. So a lot of people who have DoD contracts or work with the government closely would utilize this file format just based on that's what they use for those types of industries. The next one was the ASIS. So this stands for, it's a SAT file, and it stands for Standard ASIS Text. So this is just simply a geometric modeling kernel developed by a company called Spatial Corp, and it stores 3D geometry information in a text file format. Nothing really special here. Didn't look like anyone was really using ASIS files, so I'm not going to go into too much more detail on those. It's another option out there for dumb geometry. Don't see it very often, but it's there. So another thing, the next thing I want to talk about was some of the file categories. So basically what I did was I broke down some of these different files into the actual categories they belong in. For instance, if you're working with 2D paths, so this is like your 2D info sketch editor. These are your DWG, DXF, and Adobe Illustrator files. 3D mesh files, so these are your STL files. This is a wireframe geometry made from polygons. So this is what you would output if you're working with 3D printers. So basically you can just do save as STL, and then you can transfer that over to your printer or whatever your printer conversion software is to make a 3D print. The next one is the ones we talked about, 3D solids. So this is your typical import export methods for 3D. Parasolid, IGES, step, ASIS, we just talked about those. Then we have our CAD. So this is what's imported direct from a native format. So these are like Pro-E, Unigraphics, Inventor, CAD Key, Solid Edge softwares. Then there's the specialty files. Don't see these too often, but they're there, like CATIA Graphics, Rhino, IDF, Point Cloud, IFC formats. And then on the right there, the image, the screen capture I have, basically it's just whenever you go to the SOLIDWORKS open menu, you see a list of files that you can import. And that list is there, contained in there if you want to look at that easily. So the next thing I wanted to look at was this import diagnostics tool, and I'm going to have a couple examples here. So what this is, if you don't know what the import diagnostics, this is a very powerful tool. It's a tool to diagnose and repair common import errors. Imported surface data from these dummy geometry models can have issues that prevent surfaces from properly being converted to valid solids. And these are things like bad surface geometry, bad surface topology, maybe your adjacent surfaces are close, you have gaps created. So this allows you to repair those errors in the geometry and topology, eliminates gaps between adjacent faces, and it also has the ability to convert surface body into solid body. So let's go ahead and take a look at this import diagnostics tool and see kind of how easy it is to work with this. So all I'm going to do is go up to my open in SOLIDWORKS here, and I'm going to open up a file here, which happens to be an XB or a Parasolid file. So I'm going to open up this file, and as soon as I bring this in, it's going to take a second here, and then it's going to ask me, do I want to run import diagnostics? Yes, in this case I do. And you'll notice when I run this import diagnostics, it tells me I have a gap between faces here, and I can actually see this gap. So if I click on any of these, it'll highlight where the issue is. So you can see it's telling me that there's some issue that when I import this with this face and this other face, that there's some gaps here. So I'm going to utilize this attempt to heal all. This is a very powerful feature and function here. So if I hit attempt to heal all, best case scenario is you hope that it'll heal this. You can see in this case, what it actually does is it heals it, but it causes me another issue here. So it gives me another warning here for a faulty face, telling me I have a general geometry problem. and my last operation to repair a face has failed. So one thing I want to point out here is sometimes that you can utilize this tool. If you hit it again, it may be able to run through it and fix it. So I'm going to actually try to say attempt to heal all again on this face. So before I heal the gap, now I'm going to heal a face. I'm going to hit attempt to heal all, and hopefully it'll fix this. And you can see now it's fixed my face. I have a green check, no faulty face or gaps remain. I'm going to green check mark out of that. Usually asks if you want to proceed with feature recognition. I'm not going to do that yet. We'll come back to that one. But now what you can see here is, yes, it fixed it. I still have my imported model, and I can't, do anything with this. I can't make any changes or anything. But if I actually go ahead and look at this face, you can see that that's not quite what I wanted, right? I still have a face here, and then what it did was it gave me a bunch of other faces across this face. So that may or may not be what you desire when you're doing the feature recognition, or not the feature recognition, the import diagnostics. So in this case, this is where I'm going to talk about the direct editing a little bit. So this can get quite complex depending on the complexity of your model and the faces and what you're actually trying to fix. But there's this tool called direct editing, and you can activate this by just right-clicking up on here, enabling this direct editing, and it'll bring that menu up for you. And this gives you a bunch of different options in here, like delete body, delete face, split. There's some other things that you can do with that as well, move face, move copy. So those are all very powerful tools when you're editing these bodies like this. So in this case, what I want to do is I'm just going to select this delete face, and I'm actually going to use this command to help me fix this geometry the way I actually want it to be. So I'm going to select all these little faces here, and there should be about 12 of them. So you can see I'm just selecting all the faces. Make sure I got them all. Looks like I got them all. Okay, and then I'm going to say there's a couple options in here for delete, delete and patch, delete and fill. In this case, I'm going to utilize this delete and patch. I'm going to green check out of this. And let's see, I must have missed one. Let me look at this again. So there's a little sliver on the end I missed. I'm going to hit the green check mark. And now you can see that I've actually corrected this face the way I want it to be. So now I have one solid face across this part, which is exactly what I'm looking for here. So just by utilizing that import diagnostics and utilizing the heal face and heal gaps, and then doing a little direct editing, that was a pretty simple example. Obviously, there's much more complex examples that you can do that are going to require more time to repair. But that's a pretty good example of how you can actually repair these imported geometry bodies. So let's go ahead and jump back over to the PowerPoint. So the next thing I want to talk about was this FeatureWorks. This is a really great tool if you're going to have to edit the part that you're bringing in. So what FeatureWorks is, I feel like this is probably a highly underutilized tool. It recognizes features, pretty simple, right, on an imported solid body in a SOLIDWORKS part document. And these features are the same as created in SOLIDWORKS when you're modeling. So basically all this does is identify the features in the imported geometry for you automatically. So this is things like your extruded cuts, your revolves, your holes, bosses, ribs, that type of stuff. And it gives you the ability to edit the parts and the sketches. So it's going to save you time. You don't have to recreate this stuff. You can make changes to your imported geometry with ease. You don't have to recreate, sketches, geometry. You just bring that in, use the feature recognition tool, and let it do the work for you. So let's take a look at how it might actually go about that. So I'm going to jump back over to SOLIDWORKS, close this out. So let's open up another part. I have this real simple knob part that's a step file. So I'm going to open up this step file. And it brings that in, and you can see that this is my dumb geometry here. So there's nothing here, it's just an imported body. And what I'm going to do is I'm going to run this FeatureWorks. So I'm going to right click here on my imported body, and I'm going to say run FeatureWorks. You can also get to it through the Evaluate tab. or you can search for it. All right. Where did my FeatureWorks go? 1 second, maybe I opened the wrong one here. So I should have a FeatureWorks option in here. I'm not seeing it. Okay, let's try and open up the SAT file and see if that, choose millimeters. Basically, it'll bring it in, ask me if I want to run import diagnostics. I'm going to say no on this part. Then ask me if I actually want to proceed with feature recognition. I'm going to say yes in this case. So now you can see that it's actually bringing me into my FeatureWorks menu, which is what I originally wanted. And there's some options in here. Recognition mode, I'm just going to leave this automatic. I'm going to use, this obviously isn't a sheet metal part. I'm just going to use standard features. And then you can select, what you want to have it actually recognize. If you have some holes, you might want to check that. In this case, I know I just have fillets, chamfers, extrudes. I probably may have a revolve. I may or may not. I'll leave ribs on. I don't think I have any ribs in there, but I'll leave it on. And then basically you just go to the next menu and it does its thing. It recognizes the features. It shows you what those recognized features are. I'm going to green check out of that. And then it actually builds the part for me. So now you still see I have the dumb imported geometry here, but now I have a bunch of features. So I have a boss, I have a plane, another boss, and a couple fillets. So it actually built that part for me utilizing the FeatureWorks. One thing to be aware of if you are going to use the FeatureWorks to build your parts and actually create the features to edit the stuff, just be aware that all the sketches come in undefined. So if I open up this sketch, you can see that I'm just looking at an undefined blue sketch here. So you may want to come in here, depending on what you're actually going to edit. If you're going to make a bunch of changes, you may want to come in and add some dimensions, and you can just throw some dimensions on there, or just do fully defined sketch, then check out of it to get those sketches defined. So you may just want to do that before you go ahead and start editing things further down in the tree to avoid confusion or to avoid your model from collapsing on itself. So just be aware of that. Let's jump back into the PowerPoint. All right, so we talked about FeatureWorks. The next thing I want to kind of show a quick example of was the importing the DXF or the DWG. So this is where the 2D geometry comes in. So there is a wizard for this, makes it really easy to bring in these 2D files. You have a couple options in here. You can create a new SOLIDWORKS drawing. You can import 2D geometry to a new part, or you can import the MDT data from the file. So let's look at how we're going to turn those 2D parts into 3D. Let me close this out. So basically what I want to do here is open up a 2D DXF file. So I'm going to import my DXF. So this is a simple sketch of a spanner wrench. And you'll notice that it automatically takes me into my wizard, letting me know that I'm doing a DXF or a DWG import. Here's the options we talked about. I'm going to actually select import to a new part as a 2D sketch. I'm going to go to the next. It shows me an image of what I'm importing. And you can select different layers on here. You can change your units, that type of stuff. And then I'm just going to say next and finish. And what this is actually going to do is bring in my 2D sketch for me. So you can see that it actually converted that DXF into a 2D sketch. I didn't have to do any of this work. I'm going to do that, and then I'm just going to basically make a extruded boss out of this, leave it 10 millimeters, and I've created a spanner wrench. So if somebody sends you a DXF or something like that, that's essentially how easy it is to create that geometry. Basically just import your DXF or your DWG, into a 3D or a 2D sketch in SOLIDWORKS, and you can create your 3D geometry directly from that. And obviously you can go back the other way too. If you want to export a DXF of this, then you can export the DXF or the DWG as well. All right, so I kind of developed some of this to help you guys out if you're ever in the situation where you're going to be importing a bunch of parts, bunch of dumb geometry. So this is kind of like a best practices workflow. So the first thing we looked at some of these was the heal all option first. So whenever you bring that in, utilize that heal all option, and then don't forget about the advanced options for heal all faces, heal all gaps. And also don't forget about trying it twice. So if it's a gap and it heals and it causes an issue with the face, try to heal it again and see if that helps. If it doesn't, then you may need to go to the next step. You know, if you still have those errors, decide if you can ignore them. If it's just a part that you're using to check a fit, or if it's just a manufactured part that you want to have in your database for reference, you know, you may not need to worry about that. But if it's something that you're going to actually be editing for a new design or something like that, and you're bringing it into assembly and you need it to change some dimensions, you may need to have that corrected. The next thing is, if it's a very complex part and you have a lot of errors, maybe try another file format first. So if you're bringing in a step, for instance, and it has issues, bring in a Parasolid. If it's an ASYS file or an IGES file, bring in a step or a Parasolid. Bring in a step or a Parasolid, right? So just try another file format if that's an option. If it's not, then you can just utilize those direct editing and other techniques to repair the geometry. So those are things like delete face, splitting apart, and then you get into some advanced surfacing techniques if you're trying to repair some complex geometry on those faces. So just be aware that those options are there in direct editing if you have issues and you actually need to edit the part. It'll still save you time to bring in the 3D geometry and just make the corrections to it. So some of the benefits of utilizing this, of utilizing SOLIDWORKS for these types of operations: easily import multiple file formats. We talked about a ton of those. We have the import diagnostics, can repair your model defects automatically. And then we have powerful tools like FeatureWorks that will just build that feature tree for you. Just be aware, like I said, about the undefined sketches and making sure that you correct those things and checking your tree. It doesn't always know the design intent for that part either. So if it's something that's very complicated and it built it for you, you may want to just go through the tree and check and see how it did it, because that may not be how you want to do it. So you can rearrange some things or make some adjustments, but at least you have the base features there. And then we have those direct editing tools to fix your import errors if they are there after, the import diagnostics maybe couldn't repair a complex error. So this pretty much all translates cost and time savings. Whenever you're bringing in those files, save you a lot of time. You don't have to rebuild that geometry. Great options, great tools that are there, all included, no extra cost, right? So some upcoming content I want to give a shout out to. July webinars. We have one more tool competitive quality program on 27th. I think there may be another one next week, but I'm doing that one. That's going to be on SOLIDWORKS inspection. So if you're interested in any quality software for your QA department, that's definitely something that you might want to look into attending. And then we're going to be having 2 more of these 20-minute learning series, August and September. The next one's going to be on sheet metal design, and the one after that's going to be backbone of SOLIDWORKS structural design, which is essentially just looking at weldments. I've had a lot of demand for those, so I was hoping that they would be a lot of people would be interested in attending those. So with that being said, I'd like to thank everybody for attending, and just think about what did you see today that could benefit your company and how SOLIDWORKS can help you with those imports. And don't forget to follow us on social media, Twitter at DDICAD, and then Digital Dimensions Inc. on Facebook and LinkedIn. Once again, my name's Jared Spaniel, and I thank you guys for attending. Have a great Tuesday afternoon. I will hang out for a few minutes if there's any additional questions in the chat or anything that I can answer. And also feel free to email me your questions if you have any remaining questions. Thanks, guys. Have a good one.